Good afternoon, everybody. We're going to get started in about 5 minutes. Enjoy the pre-show. I'll see you soon.
7, 6, 5, 4, 3, 2, 1, fire!
Now we're ready for launch. Now we're ready for the rocket to fire. Amazing. I am so glad to see everybody today for Space Week Part 2. Let me say an official hello to everybody. Nice to see you today. Nice to see you. It's a beautiful sunny day outside, so I don't know about you, but after we're done, I'm going to go outside and enjoy some of the light from our beautiful star, the sun. For anybody who hasn't been here before, my name is Ryan, and I am your personal astronomer, your personal guide as we go and explore space. And this week, for Space Week, we've got 4 pretty great topics. 2 days ago now, it was Monday, we started with the Earth and the Moon and the Sun and learned lots of fun things. Today we're going to talk about planets and exoplanets. Planets are the ones around our solar system. Exoplanets are the ones that are orbiting other stars. So I've got a lot of fun ones to show you there. Tomorrow, we're going to be talking about stars, the life and death of stars, how they're born, how they live, how they die, what that means for the Earth, and for all the other stars that we're learning about in space. And then Friday, we're talking galaxies. We're going one step further into the big universe. So it's nice to see everybody join. And we've got a good big group today, which is really, really nice. I see Violet's already got a question for today, which is awesome. Do all gas giant planets have rings? Do only gas giants have rings? And why? So why don't we start with that question? Because that's really good. And usually the best way to explain gas giants is to actually go and take a look at Saturn. So we're going to go and investigate our good friend, the planet Saturn. And what better planet to start with, right? Saturn has the nicest rings that we get to explore in our solar system. I was actually doing a radio show on Monday, and we were talking about Saturn's rings. Here they are, very nice looking. We're talking about Saturn's rings because they were discovered way back when the first telescope was discovered, or was used, I should say, in the year 1609. So 412 years ago was the first time a telescope was used. But the person who discovered the rings of Saturn, his name was Galileo Galilei. What a great name, right? He also discovered all the moons of Jupiter too, but when he saw the rings of Saturn through a telescope, he didn't know he was actually looking at rings. When he saw them from far away, he thought that there must have been 2 big moons, one on either side of Saturn, that were making them happen. And the reason is that nobody had ever seen rings around a planet before. Nobody even thought that they could possibly exist. And it wasn't for about 20 or 30 years, actually about 30 years after that, that a guy named Christian Huygens, he actually looked at the rings of Saturn and realized that they actually were rings. Now, all the gas giants, Violet, in our solar system do have rings. Okay, so that's Jupiter, Saturn, Uranus, Neptune. All 4 of those planets do have rings. And the rings are actually made of a bunch of little bits of rock or dust or ice. Saturn's happen to be very visible and very bright because they're made of ice. They're made of ice, right? And ice is very, very good at reflecting sunlight. Well, most of the bits of ring around planets, Jupiter, Saturn, Uranus, and Neptune, they're very small pieces. They're about the size of your fist. So if you make a fist, that's about how big most of those bits of rings are. And they're all floating around the planets very, very slowly. In some cases, very quickly. So Saturn's rings we can see because they're bright and very icy. But rings around Jupiter and Uranus and Neptune are a lot dimmer. Like if we go to Uranus, we'll go and take a look here. 10 seconds to anywhere, right? Here we go. Here's planet Uranus. You can't really see right now, but I'm going to add the rings by making it brighter. There, you see the rings around it? So they're very hard to see. They're very, very tough to spot. They're very dark. The rings of Uranus are mostly made of dust. Now, all the gas giants in our solar system have rings. We don't know if all gas giants everywhere have rings because we haven't really seen them around other planets, except for one. I'm going to show that to you pretty soon. But typically, it's only gas giants that have planets, at least in our solar system. But that doesn't mean that other planets can't have them. Really, in order to make rings, you need something that's pretty big. That's pretty big. So if we go and we take a look at where was it? What was I going to show you? Okay. Oh yes, the other okay, super Earths. So these are planets that we've actually discovered around other stars that are super Earths, which means they're bigger, they're heavier. Some of these could have planets, and rings. Gosh, I'm having a time here. Some of these could have rings, and the reason that planets have rings is because of their gravity. Okay, they're pretty big, they're heavy, and their gravity allows them to rip rocks into pieces. So for example, if we go back to Uranus here and we see its big bright rings, what very likely happened is that a long time ago, a big chunk of rock came close to Uranus, or Saturn or Jupiter, and one of those rocks came very, very close. Now imagine this is a random rock in space. This is my squishy moon, but a random rock in space, and you have here a planet like Jupiter or Saturn or Uranus or Neptune. When the rock gets closer to the planet, the gravity changes. Gravity depends on distance. If you're closer to something, you feel more gravity. If you're farther from something, you feel less gravity. And so if this moon gets very, very close, or this rock gets very, very close to a big planet, the gravity from this planet is a bit stronger on this side, because this side's closer, than it is on this side, because this side's farther. So more gravity here, less gravity here. And that creates a difference that can rip that rock to pieces. So a rock comes very close to planet Uranus. It gets really, really close. The gravity of Uranus starts to pull on one side harder than the other and rips that rock to pieces and makes the rings. So this is why planets in our solar system, the really big ones, the gas giants, have rings, as they rip apart small rocks that come too close. Now, I'm pretty sure Earth could do that. There's a bunch of dust around the Earth, but just not enough to make a ring. However, there is a different type of ring around the Earth. And this was something I actually showed in another program not that long ago. So I'm going to share it with you because it's really, really cool. Let's go web content. Let's just look over here. All right, here we go. There is a ring around the Earth, but it's made of space junk and satellites and things that human beings put in. So you see this, here, let me fly around a little bit. There we go. You see, it's kind of hard to see, but you see the ring that goes all the way around the Earth? That's a ring made of satellites, of actually like robotic satellites that people have sent up. That's called the Clark Belt. And the reason there's a ring there is that this is what's called geosynchronous orbit. Basically, if you want to have a satellite that stays, say, right above North America, here's North America right here, and here's the Great Lakes, right? If you wanted to have a satellite that stays right above the Great Lakes as the Earth spins, you put that satellite way out here in the Clark Belt, and it'll stay right above North America. So it'll keep going around like that. At the same speed the Earth spins. Okay, so technically Earth does have a ring, it's just a little bit different. It's made by people, right? So really it's that tidal force, that ripping apart of rocks that creates rings. So all gas giants in our solar system have rings, Violet, but we don't know if other planets around other stars, exoplanets, have rings. We expect that some planets that are rocky, these super Earths, we expect that some of them could have rings, but they're very, very hard to find. And we're going to talk today a little bit more about how hard it is to find planets. It's even harder to look for things like moons around other planets. It's even harder to look for things like rings around other planets, around other stars. But we're going to get there someday. What website am I using? I'm going to show you. You mean for all the satellites, right, Jackson? Let me share that with you. So this is the satellite map that I was using. I'll just type that in the chat. There you go. So that's the satellite map. So Violet, to answer your question, all gas giants in our solar system have rings. Only the gas giants in our solar system have rings that were made naturally. And other planets around other stars can have rings, we just haven't seen them yet. Except for one. And I think this is a great introduction to a real planet around another star. I'm going to show you the planet with the biggest rings. If you've seen one of my programs before, you've probably seen this one, but I really want to show you. This planet is called 1S WASP J1407b. And the planet, you can kind of just barely see it right now, but watch what happens. So if we move around, you can see it right there. Oh, you're welcome, Violet. Thanks for your question. And by the way, for anybody who hasn't joined us for a program before, we love lots of great questions. If there's something you're curious about, something you heard about on TV or in a video or in a book, and you want to talk about it, please let me know and we can do it. Because we can literally do anything, go anywhere, see anything, and explore. That's the point of what we're doing. But look at this. This is a real planet around another star that has rings that are 100 times bigger than Saturn's. And I love showing this planet. It's super cool. It's called J1407b. The planet itself is actually bigger than Jupiter. It is huge. It's this massive, massive planet, yet the rings are what's really big. So what likely happened is maybe not just one rock, but a bunch of rocks, a bunch of icy chunks came very close to this planet a long time ago. And this planet had so much gravity that it tore them to pieces. Imagine living around this planet and looking out and seeing all these rings. Here's the planet, J1407b. Bigger than Jupiter, quite a bit bigger than Jupiter actually. There it is. That is 10 times wider than, 10 times as wide as Earth, 20 times as heavy as Jupiter. That's like basically a star. It's pretty big. So let's, actually I'm going to go through them. Whoop. I wanted to show you something really cool, is that if you can see the star back there, right? Callie says that's one of her new favorites. Yeah, totally. It's a neat one. So let's brighten it up a little bit. And you can actually see the rings. And there's the star. This is how we discovered the rings, right? Is you can actually see the light from the star bouncing, flickering as it peeks through the rings. Where is this planet? Asks Violet. This one is really far away. I think if we actually go and I can tell you the distance. If we select Earth, it's okay. This one is 433 light years away from Earth. This planet, so pretty far. It's not like crazy far, but it's far enough that we're not going to be traveling there anytime. But the way that we actually discovered it is that when this planet passed in front of the star, we saw the star flicker a bunch. And that can only be because of rings blocking out some of the starlight. There's that flickering that we see. So I am going to share with you some other things about how we actually discover planets around other stars, because I think that's kind of an important thing to talk about when we talk about planets and exoplanets, planets around other stars. But I'm going to actually start by showing you the first planet ever discovered. The year was 1992, quite a long time ago. And the first planet ever discovered wasn't discovered around a star. It was discovered around, well, not just any star. It was discovered around a neutron star. And in fact, there were two of them. So looks like I already blew that one up. This is called a pulsar. It's a rapidly spinning neutron star that creates these big flashes. It's super powerful. Let's fly in a little bit closer. It's pretty cool looking, right? And this pulsar is a star that weighs about as much as the sun, but is only as big as a city. Okay, so a spoonful of that star would weigh as much as a mountain. A spoonful of that star would weigh as much as a mountain. That's pretty insane. But it's spinning really, really quickly. These pulsars, some of them spin over 1,000 times a second. So really, really, really quickly. And actually, we found multiples of them spinning around each other before, too. These ones are going really fast. So we're having a bit of a dance party here. But I'm going to pause for a sec. Because the first planets ever discovered were actually two of them around a pulsar like this. And I'm going to place the first couple because they were found kind of out here and out here, flying around this pulsar that's moving really, really quickly. So you can see it flashing. So that was kind of weird. And actually, those planets that were discovered, the two planets, were some of the oldest planets ever discovered as well, almost as old as the universe itself. So it was a very weird discovery because we thought, whoa, hold on a second. If we're only finding planets around these pulsars, these long dead stars, does that mean that there are only planets around pulsars? Does that mean that there's no planets around normal stars? Well, 3 years later, the first planet was discovered around a sun-like star, a star like the sun. And it was called 51 Pegasi. This is a star that you can find in the night sky. There you go, in 1995, the first planet was discovered, and here it is. This is called 51 Pegasi b. Now, the reason that this planet was discovered first is very special. You know, when we build telescopes, we're always trying to make something that's bigger, that we can use to see farther, to look closer at something. Planets are really hard to find around stars, right? If we zoom out, you can see the planet now, but we don't have to zoom out very far before you can't see the planet anymore. All you see is the star, and you can see all the stars in the background too, right? So it's really hard to find a planet, especially because planets don't make their own light, right? The difference between a planet and a star is that stars make their own light, planets reflect light. Sunlight bounces off of them and then bounces out into space. So the first planets, though, that were discovered are special ones like this. They're the biggest ones, and they're very, very close to their stars. We call these hot Jupiters. A hot Jupiter is a planet that's big, bigger than Jupiter, like this. And actually, let me show you how big Jupiter is next to this one. There's Jupiter, and here's the Earth, just to give you a sense of how big these are. And I'm just going to change the lighting so we can see it a bit better. There we go. So there's Earth, Jupiter, which is 1,000 Earths can fit into Jupiter, and 51 Pegasi b, the first planet discovered around a star like the sun. So not only is this planet really, really big, it's actually closer to its star than Mercury is to the sun. Like if this star was the sun, Mercury is actually quite a bit further, about here. So this is where Mercury's orbit would be. Whoops. Why am I not seeing Mercury's orbit? There we go. So not only is it bigger than Jupiter, it's closer to its star than Mercury is. And that makes it really, really hot. Hence, we call it a hot Jupiter. The temperature of this planet is several hundred degrees. It's really big, it's really hot, it's really close to its star. And the reason that we can find it is not that we have a telescope big enough to see it. The reason we can find it is because it actually tugs on the star. All right, when things orbit each other in space, I'm going to take us actually out to Pluto for a second to show you something kind of neat with Pluto. And this really illustrates the concept. Violet says, how many Earths fit into 51 Pegasi? If I had to guess, Violet, I'd probably say about 1,500. It's about 1.5 times as big as Jupiter, so that would put us at about 1,500. Okay, so why am I showing you Pluto, though? Pluto's not a planet. It's called a dwarf planet, right? Well, Pluto has a very big moon called Charon. So this is Charon here in red. Let me just brighten it up again. There we go. And we'll turn off the galaxy so it's out of the way. So here's Charon and here's Pluto. Charon is so big compared to Pluto that it doesn't actually fly around Pluto. The moon and Pluto actually orbit a point between them. So watch this. If we let time go faster, see how Pluto is kind of going on a little circle? When things orbit each other, they don't actually, one thing doesn't really orbit something else. They actually both go around a point in between them called the center of gravity. It's kind of like a balance point. It's kind of like, you know, if you had, if you were grabbing onto somebody else's hands and you're like swinging around in a circle, the bigger person would be closer to the middle of the circle. The smaller person would go flying a lot faster, right? So it's kind of like that. So Pluto goes on a little wobble. This is the exact same thing that the stars do. It's the exact same thing that those big stars, like 51, those big planets, they pull on their stars. So 51 Pegasi b, back over here, that star is actually wobbling just a little bit, back and forth and back and forth and back and forth. That's how we can see the planet, is we actually see the star wobble. Wob, 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 back and forth, like that, from Earth. And based on that wobble, we can tell how big the planet is and how far away it is. Callie has a question in the chat. When was Saturn discovered? That's a great question, Callie. Saturn is one of the planets that we can actually see in the sky with just our eyes, right? There's 5 of them. There's Mercury, there's Venus, there's Mars, Jupiter, and Saturn. Those 5 planets can all be seen with just your eyes in the sky. And when people used to look at them in the sky, they would see them, and the planets would move a little bit differently. So here, I'm actually going to go back. Actually, I'm going to go forward. I'm going to go to tonight to show you where Mars is. There we go. So here's Mars right here. And one of the things that people notice that Mars does is that if you skip ahead a day, okay, and another day, and another day, and another day, and another day, and a bunch of days, look at Mars. It's moving differently than the stars, right? It's not moving the same as all those stars in the background. It wanders. It moves a little bit differently. And so people used to look at the planet Mars and Jupiter and Saturn and Venus and Mercury and say, wow, they're wandering. They must be special. They're moving differently than the rest of the stars that we see in the sky. People didn't know that they were planets. We just thought they were dots that were doing something different. And so we said, okay, those have to be special. So we're going to call them wanderers. And that name wanderers, if you take the word for wanderers in ancient Greek, it's actually planets. So the word planets comes from the Greek word which means wanderers. Kind of cool. So the answer to your question, Callie, is when was Saturn discovered? Because people could see Saturn in the sky, even thousands of years ago. It was discovered before people could read or write. It's been known about since antiquity, which means it's been known about longer than people could write things down. So there was no discovery date of Saturn. People have been looking at Saturn in the sky for as long as there have been people. In fact, the first planet that was actually discovered was Uranus. Kind of crazy. So here's Jupiter and Saturn right here, right? There's Jupiter, there's Saturn. You can actually see them in the sky if you get up very early in the morning at about 6 o'clock in the morning. Right now, if you get out very early, you can see them. And so like here, I'll show you 6 o'clock. Oh yeah, you can see them at, just about 6 o'clock. And then they disappear because the sun comes up. So the first planet ever discovered was actually Uranus. The other 5, Mercury, Venus, Mars, Jupiter, and Saturn, have been known about since before people could read or write or have telescopes or anything. They've been known about pretty much as long as there have been people. So if you want to go outside very early in the morning at 6 a.m., you can see Jupiter and Saturn right next to each other in the sky. And again, you can see them. And for those who don't know, if you want to find a planet without those big words in the sky, planets don't twinkle. Stars twinkle, planets don't. Okay? Thank you for that great question, Callie. And thank you, everybody, for the questions so far. I hope we're having a good time. So let's go and take a look back at 51 Pegasi discovered in 1995. After 51 Pegasi was found, a lot of other planets around other stars were discovered, just like 51 Pegasi. What is the latest planet found called? That's a good question. I think the bulk of them were discovered in. Actually, you know what? Let's look at TESS. Let's look at TESS. Violet says, "How come Uranus was discovered before Jupiter?" It actually wasn't. I'm sorry if I said something wrong. Uranus was discovered in the year 1781. So 1781, which was when Uranus was discovered. Oh, perfect. And we got some help from that too. There you go. 1781. So Mercury, Venus, Mars, oops, I gotta learn to type a bit better. Mars, Jupiter, Saturn were known about a very long time ago. There we go. So those are the 5 planets that we've known about since forever. Now I want to show you, okay, so the latest planets are actually being discovered by a spacecraft called TESS. And TESS means Tess is a really interesting name. I'm going to bring it up for you on our webpage here. TESS means Transiting Exoplanet Survey Satellite. So here, let's take a look at TESS. This is what it looks like. It's flying out in space. It's a space telescope. It stays in outer space and looks for planets around other stars. And it's looking at a huge chunk of the sky. And so I think some of the new planets that it's been discovering, like here's probably, yeah, February 12th. So here you go. These are probably the most recent ones, TOI 451. So there you go. It's a star similar to our sun. Yep, so almost as big as the sun, almost as heavy as the sun. And it's found 1, 2, 3, 4 planets. 3 planets, an asteroid belt, and another star. That's kind of cool. Right? So this is probably the most recent set of planets. And some of these planets are really neat looking. Like here you can see that this one is pretty similar in size to the Earth. It's a bit bigger than Earth. It's super Earth. But it goes around the star really, really quickly, which means it's probably really, really hot. This other one out here, 451c, looks like 3 times as big as Earth. But again, it orbits the star in only 9 days, which makes it closer than Mercury, makes it really, really hot. And same thing with this one, 4 times as big as Earth. Again, 16-day orbit, it's going really, really fast. All of these planets are probably too hot to find life. Okay? They're probably way too hot to find any life on them. But still, those are probably the most recent planets discovered. And TESS is doing it by the way, we're going to talk about how planets are discovered in a slightly different way pretty soon. But I want to continue the story about hot Jupiters. So we left off at 1995, and thanks for the question there, Roth family. That was lovely. We left off in 1995 where we started to discover hot Jupiters, planets bigger than Jupiter, closer to their star. And the reason again that they exist, the reason that we can find them is because of the wobble method, right? The star wobbles back and forth as the planet pulls on it, grabs on it, tugs on it, and makes that star wobble and bounce. A few hundred planets were actually discovered that way, and they're all really, really big, really, really hot, Jupiter-sized things. Let's take a look at maybe another one of them. I think Koros 7 is one of them. I think Koros 7, so G-type star. Yeah, okay, more massive than Earth. Those are super Earths. So again, same kind of thing. These planets are whipping around really, really, really fast. They're very, very hot. So Koros 7c, this one is, yeah, five times as wide as the Earth, 8 times as heavy as the Earth, really, really hot. This one here, same kind of thing, bigger than Earth, very, very warm. And these 2 planets are moving around really, really quickly, so they're much closer to this star than Mercury is to the sun. So again, these were the planets that were discovered first. And then came along a brand new type of telescope. All right, a brand new type of telescope called the Kepler Space Telescope. So the Kepler Space Telescope, let's take a look at it a little bit. All right, the Kepler Space Telescope looks for planets around other stars by looking at the light from the star. Oh, Gracie's got a good question. I would like to know where the planet Earth comes from. How is it created? That's a lovely question. Let's definitely talk about that. We'll come back to the Kepler Space Telescope. It was actually launched in 2009. I'm just going to finish my thought, Gracie, on this thing, and then we'll talk about how the Earth was formed. Okay? So now, this is the way we discover planets around other stars today. When a planet passes in front of the star, it blocks out some of the light from the star. And that makes the brightness of the star get a little bit lower. It makes it get a little bit dimmer. Right? It's like putting a finger over the sun to block out the sun, kind of like that. And if the planet's bigger, it blocks out more of the star's light. If it's smaller, it blocks out less. If it takes a long time to go across the surface of the star, the planet's farther away, right? Just like this one, the planet that's closer is moving faster. That's true for all planets around all stars. If you're closer to the star, the planet moves faster. So if we were watching this planet from Earth and we see the planets go in front, so let's see one of them go around here, we can tell Okay, there's the small planet going in front of the star. Really, really tiny. It blocks out a tiny little bit of the starlight, and it goes across really, really fast. We know that that's a small planet that is very close to the star. Now, for the bigger one, we're going to see the bigger one cross in front of the star in a second. Here it comes. We'll pause it again. There it goes. Look how much bigger that planet is. It blocks out more of the starlight, so the star looks dimmer. And because it's farther away, the planet passes over the star a little bit slower. So this is how we find planets today, and the Kepler Space Telescope uses this method as well. Now, using that, the Kepler Space Telescope discovered over 5,000 planets, which is kind of amazing. And I'm going to show you exactly where they were discovered. And then, Gracie, we're going to answer your question. Thank you for that, all right? So let's see here. All right, I'm going to show you all the planets that Kepler found. Look at this. You see that grid? Every green circle is a star where planets were discovered. And this is where the Kepler Space Telescope looked. It looked in all of these little grids and looked at stars and looked at the brightness of those stars and said, okay, they're getting dimmer. There must be a planet there. And it measured how big the planets were. It measured how far away they were from the star. 5,000 planets just in this little clump of space, this little area of space. And that means that just looking here is kind of random, right? We look here and it's like, look at all those planets that we found just here. What about over here? We should see the same thing. What about over here? We should see the same thing. So there are planets all over the sky. They're all over the place. And that's what Kepler did from 2009 for about I think it was about 10 years. 9 years, yeah, 9 years, 7 months it operated, so that's kind of cool. And it found all those planets. Okay, let's do Gracie's question. Where did planet Earth come from? How is it formed? Well, if we actually go back and look at our solar system, there's one very important clue. So like if we look at our solar system with all of our 8 planets, Mercury and Mercury and Venus, Earth and Mars, Jupiter and Saturn, Uranus and Neptune, our solar system is actually flat. And that's a very important clue. Our sun was born the same way that all stars are born. And that is in a very special part of the sky, a giant cloud called a nebula. So I'm gonna show you an actual nebula in the sky because they're really quite beautiful. They're really quite beautiful, and I think there's one over in the west. What star is that? That's Capella. Okay, so let's bounce back just a little bit, and I'll show you a really good one. There we go, perfect. Okay, so there's a lovely little nebula right over here. Oh, where is it? Why am I not seeing it? Oh, okay, I know where it is. Haha, there it is. All right. This is called the Rosette Nebula. So this is like a giant cloud where new stars are being born. And when those stars are born and the planets around them, the light from the star shines and causes all the gas and the dust in this cloud to glow. So these are all very brand new stars, which is kind of amazing. So when our sun was born, it formed first in this cloud, and then all the planets formed around it. So let's take a look at how that happens. All right, Gracie. Now, it's not in French. I'm going to narrate this for you, though. But basically, that big cloud starts to shrink down. Gravity, the same thing that keeps all of us stuck to the Earth, pulls that cloud in and makes it smaller and smaller. And as it shrinks, it does 2 really interesting things. It starts to spin really, really fast, and it gets flat, like a Frisbee. Okay? I'm not going to explain why that is. It takes a little bit of understanding that you'll learn about in high school. But basically, we end up with a big, flat, spinning Frisbee of stuff. Now, in the very center, most of that stuff ends up in the very middle and makes it hotter, and it gets hotter and heavier, and it gets hotter and heavier and hotter and heavier and hotter and heavier, and makes the sun. The sun is born. A star is born in the middle. But the leftover stuff, those little bits of dust, they start to smash into each other and stick together and become rocks. The rocks smash together and become boulders. The boulders smash together and become mountains. And the mountains smash together and become planets. And the biggest ones, they suck up all the leftover gas with their gravity and become the gas giants. The smaller ones, like Earth and Mercury and Venus and Mars, they get a little bit of the air, a little bit of the gas, but they get a lot of water, and they stay a little bit closer to the sun. This is how all the planets were born, Gracie, and this was how they all formed. They formed from what was left over after the sun was born, 5 billion years ago. And after many, many years, hundreds of millions of years of this stuff crashing together, we end up with the planets of our solar system. And after another 4 or 5 billion years, we end up with this nice, beautiful solar system with 8 planets, 5 dwarf planets, over 200 moons, and countless comets and asteroids, but with one sun, with one star. And the reason our solar system is flat is, just like I said, when the solar system was born, it flattened out like a frisbee, and that frisbee shape we still see today. And all stars are born that way. And all stars are born inside those big clouds called nebulas. So Gracie, this is how all the planets were born. This is where they were born. And then gradually all that gas flies away or disappears, gets swallowed up by stars. The stars drift apart from each other, and we end up with all those stars with their own planets, their own solar systems flying around. Great question, Gracie. Thanks for asking that. Violet says, is the Kepler Space Telescope always going to point in this direction, or is it going to be turned somewhere else in the future? So Violet, that's a really good question. If we actually go back to Stellarium, oh no, we're still in Stellarium. Look at that. So I can go back and find where Kepler is if we bring up planets again. By the way, all these green dots are places, they're stars where planets have been discovered. Yeah, I like that video a lot, Violet. It really shows very well how how planets are made and how stars form. Okay, so let's go and see the Kepler field again. Callie asks, do all stars have a solar system? We're pretty sure, Callie. We're pretty sure. I'm just going to bring up our Kepler field, and then I'll answer that question. Whoops, I went too far. I went to morning. We need to go back a little bit. There. Where's Kepler's field? Oh, I know why, because I wasn't zoomed in. There it is. Okay, sorry about that. Okay, so first off, we're gonna answer Violet's question: is the Kepler telescope always going to point in this direction, or is it going to be turned somewhere else? The Kepler telescope was always made to be pointed at just these stars, and the reason is that this is actually right along the Milky Way. It's kind of hard to see the Milky Way, but if I get rid of that, you can see the Milky Way is kind of the bright light along here, and there's more stars along the Milky Way, which means there's a lot of things that we can see. A lot of things that we can see. A lot of stars that we can look at. And so the Kepler telescope just focused on this area of sky, and the reason is that this is pointed away from the sun, so that when the telescope is working, it doesn't accidentally get sunlight in it that blocks, that ruins it or damages it. So it just looked at these stars only, and it did it for 9 years. So from 2009 till about 2017. And then it ran out of fuel, it broke down, and that's it. So it's done. So it's not operating anymore. But during its time, it found all of these different planets around stars using that little method, that transit method that we talked about. But there's actually a problem with this transit method, right? And this is where we're going to answer Callie's question. Do all stars have a solar system? You notice that you can only see a planet here if it passes in front of the star. You can only see the planet when it passes in front of the star. What happens if you have a planet that doesn't go in front of its star like this? What happens if the planet goes around like this, assuming my head is the star, right? What happens if it goes around like this? What do we do then? We can't discover it. We can't find it. So astronomers, instead, they do a little bit of math. And I'm not going to make you do math, don't worry. But basically what we say is, okay, we've looked at this many stars here, and we found this many planets. we've looked at this many stars in the sky and we found all these planets. If every star, or say if 1 in every 10 stars has a planet that passes in front of it, then we should only be seeing 1/10 of all the planets. Okay? Basically, what the scientists did is they said, okay, if we do a bit of math and we do some statistics, we figure out how many planets we found, how many stars we've looked at, and we do some math, we can figure out how many stars should have planets. And Callie, the answer is every single star should have a solar system. Every star. Not just these ones. All the stars. Every star that you look at in the sky should have planets. And some of them could have 5 or 10 or 50 planets. We just haven't found them yet. But based on what we have seen, every single one of them should have planets. Maybe they have really big ones, like the hot Jupiters that we looked at. Maybe they have really small ones. But every star should have a system, a planetary system. And one last thing about your question, Callie, you said, do all stars have a solar system? The solar system is the system of planets around the sun. The sun is actually known as Sol, S-O-L. And so the solar system is all the planets that go around the sun. So planets around other stars would make up star systems. Okay. It's too bad Kepler can't be used anymore. I agree. It was awesome. But that's okay, you know, because we have a new mission like TESS. So, yeah, I wanted to show you what... I actually wanted to just talk a little bit more about TESS, because TESS launched in 2019 after Kepler couldn't be used anymore. However, there are planets that have been found by using telescopes on Earth, too. In fact, I'm going to show you one. Let's see. Okay, do I have a picture of it? I do. Okay. This is a real image from a telescope of 2 planets around a star called Fomalhaut. And I'm going to search up that star too, because I think it's good to look at. Fomalhaut. And it is... Okay, so I'm just going to find the star too. But that's kind of cool. Those are 2 real planets that are traveling around. Ooh, let's go back just a little bit. Darn, okay. And okay, when we look at the star in the sky though, it's actually, let's see it. So this is a star. Those are 2 planets. They're both hot Jupiters. They're really big Jupiter-sized planets. And if we look here, this is the star in the sky. No matter how much we zoom in on it, we can't see those planets. You need a really big telescope to do it. But this is the star called Fomalhaut that has 2 planets that were discovered by a telescope. An actual telescope on the ground, kind of like, you know, one of these, you know, something like this one, discovered from the ground. So so I guess what I'm getting to is that there's a few different ways that we can discover planets. We can either actually take pictures of them with big telescopes like this one. We can use the transit method where they pass in front of their star. We can look at the wobble, just like we do with Pluto and Charon, the gravitational wobble. And those are all perfectly great ways to find planets around other stars. But we're actually getting to a point where things are going to get really exciting, because now, not only are we finding planets around other stars, we're finding Earth-like planets around other stars. We're finding planets the same size as Earth. And that's exciting because we want to find places that we can go. We want to find places where humans can travel. We want to find places where humans might be able to live someday. And so we're looking for planets that have water, that have air, places like this. But how do we know if a planet has water? That's really tough, right? Let's go back to our solar system and take a look. When we look at planets around other stars, like these ones here, although this is our solar system, right? So it's the sun, we have, you know, Mercury and Venus and Earth and Mars. We look for a very special place called the Goldilocks zone. There it is. So we see 3 different colors here. Green is good, right? Green is good. So when we look for liquid water, for water to be liquid, it has to be between 0 degrees and 100 degrees. Whenever you boil water in a kettle, it gets to 100 degrees. So if the water gets to be 100 degrees, it's going to boil away. If the water gets too cold, if it gets down to 0 degrees, it freezes and you get ice. So if we're looking for liquid water on a planet around a star, we need to find where the temperature is higher than 0 but lower than 100. And we call that the Goldilocks zone. Because if you remember the story of Goldilocks and the Three Bears, Goldilocks tried the porridge, right? And one bowl of porridge was way too hot. One bowl of porridge was way too cold. But one bowl was just right. Not too hot, not too cold. So for a planet, if it's too close to the sun or another star, the planet gets too hot, the temperature's over 100 degrees, and any water boils away. If the planet's too far away from the star or the sun, it's too cold, it gets below 0 degrees, and the water freezes as ice. But if you're just at the right distance, like with Earth here and Mars, you can have liquid water. And it's absolutely true that both Earth and Mars both have liquid water. Mars is still pretty cold, so it only has liquid water for a little bit of time, but Earth, we know, has a lot of water, right? It's nice and comfortable. It's a great place for us. So when we look around other stars, though, and Abigail, I do see your question. I'm going to get to that in a second. If we get rid of the sun and replace it with another star, like Sirius, which is a bigger, brighter star, suddenly the Goldilocks zone is somewhere else, right? Now, Earth and Venus and Mars and Mercury are way too hot. So we have to look for planets that are farther away. Jupiter and Saturn could have liquid water if they were going around this star, Sirius. And then it's still, Uranus and Neptune are still too cold. But what about another type of star that's very small, like this very small star called Proxima Centauri? That's a red dwarf star. Around that star, even Mercury would be too cold. So it really depends on what kind of star you're looking at. So when we learn about planets around other stars, we look for planets that are in the habitable zone, but we have to learn about the star so we know where that habitable zone is. But all of these planets that we can see here, these ones that I showed you before, those are all planets that are bigger than Earth that are in the habitable zone, the Goldilocks zone. Kind of exciting. Abigail says, how do they know where to put the telescopes? Like in space or on Earth, Abigail? Because I'll answer both of those. On Earth, telescopes usually go on mountains. The reason is that mountains are very, very high up. And because they're really high up, there's less air. And because there's less air, we can see more stars more clearly. The stars don't twinkle as much when there's less air. So it's a lot easier to get nice pictures of stars and planets and all kinds of things. The second thing about being in a mountain, not only do they place them on a mountain, they actually place them on mountains on very dry places, like a desert. So some of the best places to put telescopes are on really tall mountains or in really dry deserts. Because again, if the air is really dry, there's less moisture, less water in the air to block out stars and to kind of make clouds, all that kind of stuff. So on Earth, we put telescopes on top of mountains and in very dry places. So some of the popular places would be in Hawaii, the big mountain called Mauna Kea. There's a ton of telescopes on Mauna Kea, and actually I'm going to see if I can get a good picture of it. So Mauna Kea telescopes. See if we can take a look at a good photo of the telescopes of Mauna Kea. Yeah, here you go. Let's see if we can open image. Well, that's a really small one. I'm gonna try and find a bigger image. All right, let's see. Here we go. Oh, that's slightly bigger. All right, well, we'll give it a shot. This is actually not a great photo, but I'll do my best. I'll do my best to show it to you. So let's see. Let's go over here. These are all telescopes on what's called Mauna Kea. And I'm gonna bounce back and forth as I zoom in on this. There you go. So this is at the summit, the top of the mountain in Hawaii. in Hawaii. All right, and these are all active telescopes on top of this mountain in Hawaii, where it's very dry, very clear. The weather's always good. It's really, really nice. So this is where we put telescopes on Earth. This one I think is in Chile, which is in South America, and Chile is basically a big desert. It's in the Atacama Desert on top of a mountain. In space, when we put telescopes in space, we have to be a little bit more careful. Space telescopes are great because there's no air, there's no moisture. The weather is always good, right? So the Hubble Space Telescope can do a lot of really great things. But the problem is that if you're pointed at the sun, it's really, really hard to see anything. So when we like here, we're going to replace this with the sun again. And I'm just going to get rid of the habitable. Let's put the sun back. There it is. Okay, so when we place a telescope in space, we want it to face away from the sun. So often we'll put it on the nighttime side of Earth, pointing out into space so that it doesn't point towards the sun. And then that way, there's actually a point way out here, about where the mouse pointer is, where you can put a telescope and have it stay there. And if it stays there, it's great because you can always point out into space and never point at the sun. So like as the Earth travels around the sun, the telescope would be right here, constantly moving with the Earth, but always pointed out into space. So you can run that telescope pretty much all the time. So that's a really valuable place to put a telescope. Thanks, Abigail. Can you tell us about the Big Rip? The Big Rip, the idea, I think behind the Big Rip is that's something about the universe. And that's probably like the universe growing really quickly. I don't know a lot about that, to be honest. And plus, it's not really what we're talking about in the program today. Maybe I'll do some research on that, and we can talk about it on Friday when we do galaxies, because then we can talk about galaxies and the universe and kind of how the universe was born and what's going to happen with the Big Rip. Let me just verify though what the Big Rip actually is, because I'm kind of curious. So, Big Rip. Oh, okay. Yeah, okay, that makes sense. So it's the universe expanding really, really quickly in the future, and basically all the atoms and molecules rip apart. That could happen, but we'll talk about that maybe on Friday. Okay, so remind me then, and we'll cover it a little bit more. But if we go back to exoplanets, the things that I wanted to do was to talk about some of these ones that Kepler found, to talk about some of the other exoplanets that we know about in space, for a good example is actually the TRAPPIST-1 system. This one's really neat. So for our last few minutes, we're going to talk about TRAPPIST-1. We're going to talk about some of these other planets that are in the habitable zone. Now, TRAPPIST-1 is called a red dwarf star. It's very, very small. It's not very hot. And so the habitable zone is really, really close to the star. But look at this. This system actually has how many? 1, 2, 3, 4, 5, 6, 7 planets. 7 planets. That's amazing. And 3 of them, 1E, 1F, 1G, are all in the habitable zone. They're all in the place where they could have liquid water and maybe even life, which is really exciting. However, these 3 planets, they travel around pretty quickly. They all orbit the star in just a few days. Like TRAPPIST-1e, let's see if we can find its orbital period, 6 days. So, like these planets take 6 days to go around the star. 1 year on that planet is 6 days. 1 year on this one, how many is that? Let's see. 9 days. So, even though these planets are places that you could live, they could have liquid water, they're very, 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 very close. All right, so TRAPPIST-1, pretty interesting place. There are some others, and this one's exciting because it actually has 7 planets, which is really neat. Earth-like planets, let's see. Kepler 186 is a really good one. Excuse me. Kepler 186f is a planet in the habitable zone, and we're going to go and take a closer look at it. We don't know what it looks like. That's kind of a weird looking graphic, but It's also because the habitable zone is up, so that's better. That's a crazy looking planet. Why don't we actually go there in Space Engine and see what it looks like with our last few minutes. Okay, let's pause time. Kepler 186f. So Kepler 186f. There we go. Flying through space to Kepler 186f. It's about 700 light years away, pretty far. But here is that planet traveling around a star. And this is a place that could have liquid water. It's a pretty comparable planet to Earth. It's about the same size, the same weight. We don't know what it actually looks like, but this is what you could imagine it looking like. Imagine we could travel a little bit closer to it, and we see it could have air, it could have storms. This is a planet that could have liquid water. It's called a super Earth, or an Earth-like planet. That's Kepler 186f. So there are a lot of really interesting ones like this where we could find life, we could find water someday. And if you think about how every single star in the sky, right? I'm sorry, we're getting to here. Let's bounce around to nighttime. Oh yeah, I turned off the ground. That's why. Whoop. Oh my gosh, what am I doing here? There we go. Let's let the sun go down. Right, so thinking about how every single star should have a planet, should have a solar system, there's still a lot to explore. And although we've only found about 5,000 planets around other stars, we're starting to find ones that are the same size as Earth. And in the future, we're going to find ones that are smaller than the Earth. We're going to find ones that are just as far away from their star as Earth is from the sun. We're going to find another Earth in probably the next 20 years that is exactly the same as our planet Earth. And it might be using that TESS telescope. It might be using the transit method. It might be using the wobble method that we talked about. But there's a lot more that we haven't even discovered yet. And it's all steps along the path to figuring out what the universe really is made of. How many Earth-like planets are there? How many places are there for us to travel to? How many places are there for humans to live someday? Are there a lot? Are there only a couple? Is Earth really just unique? Is it just one planet there's only one Earth and there's no others? Right? What about the Kepler planets? Are there all those Kepler planets out here? Are any of those able to support life? Do they have water? Do they have air that we could breathe? This is some of the questions that we ask ourselves. So although we found about 5,000 different planets around other stars, there's still a lot more to discover. Because remember, even though we found this in this part of the sky, you can put that field anywhere. You can look over here and you should see the same thing. You can look over here and you should see the same thing. All those stars have planets that we just haven't found yet. Right? So we're gonna finish up in about a minute. We're just about done. And look at that, I'm actually on time for once. Who knew? So what did we talk about today? We answered a question about gas giants first. So we talked about some of the planets that have rings and how they make rings. Thank you for the 2 o'clock warning. Perfect. I always have great timekeepers in my chat who keep me on time, right? So we talked about gas giants and how they have rings, and how there are other planets that can have rings, but usually the bigger ones have the gravity to rip apart rocks and make rings. So we don't know if all gas giants have rings, but at least the ones in our solar system. We talked about the first planet ever discovered around a pulsar, this spinning neutron star. And then we talked about the first the first planet around a sun-like star, the hot Jupiter, the really big, really hot ones that are closer than Mercury, but bigger than Jupiter, but closer than Mercury. And we talked about how we find those by the star wobbling. And then we talked about the transit method, where a planet passes in front of the star and lets us see it, and how the Kepler Space Telescope discovered tons and tons and tons of them. And then after that, we talked about TESS, the Transiting Exoplanet Survey System, finding the most recent planet that was discovered just 2 months ago. So new planets are always being discovered. And then we talked about the fact that every single star should have at least one planet. Every star is a sun with its own system of planets and moons and comets and asteroids. And there's still a lot to discover. And then finally, we talked about how do we find planets that are like Earth, that could have water, that could be places that we could visit someday. And so I think that's it for this one, for planets and exoplanets. Tomorrow, we're talking about the life and death of stars. Of course, feel free to ask questions about anything, anytime. And if you want to find more fun stuff, you can always find me at Astro in Action. It's always a pleasure to see you. And I hope to talk to everybody again. One last thing in the chat. Callie says, thank you for answering my questions. And I want to tell you that I got a baby bird. He's a cockatiel that we named Kiwi. Well, I hope that Kiwi can explore space with you, Callie. And I hope that we can hopefully get to meet Kiwi someday. At the very least, I'm sure Kiwi's going to watch some of these programs with you. So I'll get to say hello to Kiwi at some point. For everybody else, we'll talk to you again tomorrow. Sure, Jackson, we can probably go over time tomorrow. We almost always go over time, but I try and keep it at the hour. So anyway, go enjoy the lovely day that we have outside. Thanks for watching, and I hope to see you again tomorrow for Stars, Life and Death of Stars. Goodbye, my friends. See you next time.